Bismillahirrahmanirrahim. This is course Oxidation Reduction and the course code is Oxidation and the course code is Chem 421. Our today's topic is about the oxidation of carbon-carbon double bond, that is olefinic double bond with a powerful oxidizing agent potassium permanganate. So the outline of the present session will include the oxidation of olefinic double bond, types of oxidation, and we will use over here in this session potassium permanganate as an oxidizing agent. So you know that oxidation of carbon-carbon double bond is of three types: hydroxylation, oxidative cleavage, and epoxidation. We will learn today how this potassium permanganate carry out any type of oxidation of carbon-carbon double bond and in what experimental condition hydroxylation is carried out and oxidative cleavage is carried out. Epoxidation is not carried out with the potassium permanganate. So these are our learning outcomes. First of all, potassium permanganate, it's a very powerful oxidizing agent and is of prominent purple color. So it is the formula of potassium permanganate. It can oxidize in acidic as well as in alkaline or even in neutral media. So it's a very powerful oxidizing agent. So you need to learn that in acidic media, what happened to the potassium permanganate. Let's suppose potassium permanganate, if it is treated with sulfuric acid, it gives you potassium sulfate, manganese sulfate, and manganate ion, which is a source of atomic oxygen. It means that it is the source of oxygen, and this means that it is a good oxidizing agent. And after that, after oxidation, it is converted into manganese +2. आप एक्सपेरिमेंटली ऑब्जर्व करेंगे कि ये प्रोमिनेंट पर्पल कलर जो है आफ्टर ऑक्सीडेशन गायब हो जाता है, कलरलेस हो जाता है और ये इंडिकेशन होती है कि ऑक्सीडेशन ऑलमोस्ट कंप्लीट हो गई है। और अल्कलाइन मीडिया में या न्यूट्रल मीडिया में भी पोटेशियम परमैंगनेट सोर्स ऑफ ऑक्सीजन का काम करता है। It is when it is dissolved in water or in alkaline media, it will give you potassium hydroxide, manganese dioxide, and manganate ion. Again, this is also a source of oxygen, will act as an oxidizing agent, but somewhat mild as compared to the acidic condition. So you will get again manganese dioxide at the end. पोटेशियम परमैंगनेट इतना पावरफुल है कि ये सारे कार्बन कार्बन बॉन्ड, कार्बन हाइड्रोजन बॉन्ड, जितने भी कार्बन हाइड्रोजन बॉन्ड वीक होंगे या कार्बन कार्बन बॉन्ड होंगे, ये उनको पाई बॉन्ड को भी ऑक्सीडाइज करता है। कार्बन कार्बन पाई बॉन्ड जैसे कि एल्कीन में, अल्काइन में, या वीक कार्बन हाइड्रोजन बॉन्ड जो कि बिल्कुल नियर हो, अल्फा पोजिशन पे हो एरोमेटिक रिंग पे, जैसे टॉलवीन का CH बॉन्ड है, इसी तरह CO बॉन्ड है अल्कोहल में, अल्डिहाइड में। वीक कार्बन कार्बन बॉन्ड जो है वो ग्लाइकोल में भी हो सकता है, नेक्स्ट टू ऑक्सीजन भी हो सकता है। लेट्स सी सम एग्जांपल्स। ये है टॉलवीन। व्हेन पोटेशियम परमैंगनेट इज ट्रीटेड विद दिस वन, दिस कार्बन हाइड्रोजन बॉन्ड इज ऑक्सीडाइज्ड, you get benzoic acid. Similarly, this is N-propylbenzene. This carbon hydrogen bond is oxidized and you get again benzoic acid. In this case, this carbon hydrogen bond is liable for oxidation and this is also liable for oxidation. So you will get this phthalic acid. So you get this oxidation due to the carbon hydrogen bond. This is weak near to this one, alpha to this. So in case of tertiary butyl, this is tertiary butyl benzene, there is no carbon hydrogen bond. So no oxidation take place, no reaction take place. So here is the carbon hydrogen bond which is oxidized in even in this medium. So potassium permanganate can oxidize also this phenol into this quinone. This is benzoquinone, this is quinone. So this phenolic hydroxy group, it is oxidized to quinone. So this is coupled oxidation and reduction occurring at the same time. So as I have mentioned you that the carbon-carbon double bond is oxidized and there are three types: hydroxylation, oxidative cleavage, and the third type is epoxidation. As we are concerned with the potassium permanganate, mostly you will observe this hydroxylation and oxidative cleavage. Hydroxylation is the process of formation of hydroxy group alcohol from CH. So you will get at the end dihydroxylated product. Oxidative cleavage is the process in which there is oxidation along with the breakage of the carbon-carbon double bond. This carbon-carbon double bond is broken down along with the oxidation, and you will get at the end carbonyl compounds. So oxidative cleavage, the product is carbonyl compounds, and hydroxylation, the product is diol or hydroxy compounds. So in epoxidation is the oxidation of carbon-carbon double bond in such a way that oxygen is inserted across it and you will get epoxide. So you will not observe epoxidation with potassium permanganate. So potassium permanganate can act as oxidizing agent, mild oxidizing agent if it is a cold condition and alkaline media or neutral media. It will give you dihydroxylated product. So you will get mixture of these two isomers. But in both cases, this carbon-carbon double bond has gotten two hydroxy group. This is called hydroxylation. Similarly, cyclohexene will give you this cis-1,2 cyclohexane diol. This is cyclohexene with osmium tetroxide. Again, this gives you this diol. However, this potassium permanganate, if it is taken in acidic media, it is so strong that its intermediate is broken down into two fragments, into two products. So why? Because oxidation along with the breakage of this carbon-carbon double bond take place. So this is called oxidative cleavage. And in the presence of acid, it has given you this ketone or aldehyde, depending upon the this one. That aldehyde is further oxidized to give you carboxylic acid. So epoxidation is somewhat different. You cannot carry out this epoxidation with a potassium permanganate. You can carry out this by per acids. We will discuss it later on. Our experimental observation are a little bit different in acidic media and in basic media. एसिडिक मीडिया में जब आप ये ऑक्सीडेशन करते हैं तो आप देखते हैं कि पर्पल कलर जो सोल्यूशन का था पोटेशियम परमैंगनेट का वो बिल्कुल गायब हो जाता है और कलरलेस सोल्यूशन देता है, जो इस बात की इंडिकेशन है कि हाइड्रोक्सिलेशन हो चुकी है। लेकिन अगर आप एसिडिक मीडिया में ये जो है वो हाइड्रोक्सिलेशन हो चुकी है और फिर वो फर्दर ये भी हो सकता है कि अगर आप उसको हीट अप करें तो वो ऑक्सीडेटिव क्लीवेज भी हो जाए। पोटेशियम परमैंगनेट बेसिक मीडिया में पर्पल कलर से कन्वर्ट हो जाता है इनटू डार्क ग्रीन कलर, और वो डार्क ग्रीन कलर फिर डार्क ब्राउन प्रेसिपिटेट्स में कन्वर्ट हो जाता है, जो कि बेसिक मीडिया में इंडिकेशन है कि ऑक्सीडेशन इज ऑलमोस्ट कंप्लीट। ये स्लाइड यहाँ पे आपको ये दिखाया गया है कि कार्बन कार्बन डबल बॉन्ड व्हेन इट इज ट्रीटेड विद पोटेशियम परमैंगनेट इट गिव्स यू दिस इंटरमीडिएट, and upon basic hydrolysis it gives you this one, and upon acidic media it gives you oxidative cleavage. So there is a difference of media, how this is broken down in a basic media into hydroxylated product, and in acidic media it is converted into oxidative cleavage products, carbonyl compounds. Here, this is syn addition, means that both OH will be introduced from the same phase, on the same phase of the carbon-carbon double bond. As you see here, these two are on the same phase. So that is why you will get cis type of diol, and this type of addition is called syn addition. Here, this is carbon-carbon double bond in the presence of potassium permanganate in acidic media. This intermediate has been formed in acidic media. This acidic can attach, they can attack on this oxygen, and you will get this type of product intermediate like this. Water is removed, and then this is removed, and you will get this dihydroxylated product. In cold or dilute acidic condition, you have gotten this you have observed syn addition, and we have obtained cis-1,2-diol. However, if you carry out this oxidation at high temperature with a concentrated acid, then obviously there will be oxidative cleavage and you will get two different products. One is, if it is ketone, then it is one is ketone. If one is aldehyde, then that aldehyde is further oxidized to carboxylic acid. Ultimately, you will get ketone and carboxylic acid, the mixture of these two compounds. Similarly, oxidative cleavage of this type here is formaldehyde first form, which is further oxidized to carbon dioxide. This is cyclohexene. When it is treated with potassium permanganate in first case, then syn addition take place. And as you know that we are using concentrated acid at very high temperature. First of all, it is converted into this aldehyde, dialdehyde, which is further oxidized to give you carboxylic acid. So this is the summary that we have discussed today, how the potassium permanganate and experimental conditions affects the oxidation of carbon-carbon double bond with the potassium permanganate. We have also learned that potassium permanganate is a very powerful oxidizing agent. It can carry out oxidative cleavage as well as hydroxylation. So this is the end of the lecture. So we have learned today about the oxidation of this carbon-carbon double bond with potassium permanganate, covering its different aspects.